Something is unfolding right now that has every major space agency on high alert. The interstellar object known as 3I Atlas, only the third confirmed visitor from beyond our solar system, has just done something scientists believed was impossible. It altered its trajectory, not marginally, not gradually, but in a way that violates every established principle of orbital mechanics. For the first time ever, the International Asteroid Warning Network, a United Nations-backed global defense coalition, has begun actively tracking an object that did not originate in our solar system. And the question is obvious. Why now? Why this object? Because new measurements indicate that 3I Atlas is not where it should be. Not according to NASA's Jet Propulsion Laboratory, not according to orbital forecasts, and not according to the fundamental laws of physics. If this object truly changed its path while skimming the sun, then what we are witnessing may not be a rare cosmic glitch. It could be deliberate. The International Asteroid Warning Network, or IAWN, exists for a single purpose: identifying and preparing for threats capable of endangering life on Earth. It brings together the most powerful observatories on the planet, from NASA and the European Space Agency to China's Purple Mountain Observatory. Until now, its focus had always been limited to near-Earth asteroids, objects formed within our own solar neighborhood. But in late October 2025, the network made a stunning move. For the first time in its history, it announced it would begin tracking an interstellar object, 3I Atlas. Officially, the goal was to improve astrometric precision on comet-like bodies. Unofficially, the timing raised serious questions. Just days earlier, 3I Atlas had slipped behind the sun. When it was expected to re-emerge along a predictable arc, independent astronomers began noticing subtle discrepancies. The calculations no longer aligned. The equations failed. Harvard astrophysicist Avi Loeb, creator of the Loeb scale, had already rated 3I Atlas a 4 out of 10 in terms of artificial probability. After these new irregularities, the IAWN quietly elevated it to a priority target. Hundreds of telescopes were redirected. It was as if Earth itself was bracing for something it wasn't meant to anticipate. The first clear warning came from a respected independent research group known as Earth Exists. By comparing real-time telescope observations with JPL's Horizon System predictions, they uncovered a discrepancy that exploded across headlines overnight. 3I Atlas wasn't merely a few hundred kilometers off course. It was 1.1 million kilometers away from its predicted position, nearly 3 times the distance between Earth and the Moon. The shift wasn't random. Its distance from the Sun remained consistent, but its position across the sky had moved laterally, as if the object had slid sideways through space. That shouldn't happen. Comets can accelerate forward or backward through outgassing, but they do not move sideways. Achieving that would require either an immense external force or a powerful internal one. Even the largest comet ever observed, Hale-Bopp, could not perform such a maneuver with that level of accuracy. Yet, 3I Atlas had done exactly that. If the object adjusted its path intentionally, someone would have noticed long before the public did. And that's when attention shifted to NASA and JPL. As early as September, NASA's Mars orbiters were ideally positioned to capture high-resolution images of 3I Atlas during its close solar pass. Those images have never been released. Not a single frame. Officially, the data is still under analysis. Unofficially, critics suspect something more deliberate. If those images revealed structural geometry or light behavior inconsistent with a natural object, NASA would have every reason to delay publication. In one of his recent papers, Avi Loeb noted that 3I Atlas displayed an anti-tail, a jet of material pointing toward the sun, an extremely rare phenomenon. After the Mars flyby, that tail abruptly flipped, flowing outward again, as though the object had reoriented itself. No natural comet has ever reversed a jet so cleanly. Yet NASA continues to describe the behavior as routine, which raises the obvious question. If it's routine, why is the Planetary Defense Network involved at all? By the end of October, new tracking data confirmed what many feared. The deviation was real. Over just 19 hours, The positional gap widened by more than 4 arcminutes, equivalent to hundreds of thousands of kilometers. Orbital analysts calculated that sustaining such drift would require a lateral velocity of nearly 4 kilometers per second, more thrust than some human deep space probes can generate. Speculation erupted. Some blamed outgassing. Others pointed to solar wind. But solar wind doesn't push objects sideways with precision. If the data was accurate, 3I Atlas would require a propulsion system capable of sustained, controlled acceleration. Meanwhile, the IWN's emergency workshop on unpredictable comet behavior filled within hours. Behind closed doors, NASA's Planetary Defense Office quietly raised its monitoring level, the same classification used for potentially hazardous asteroids. The irony was unmistakable. The object wasn't approaching Earth. It was moving away. So why the concern? Some believe the answer lies in what happened next. Just as astronomers thought the anomaly had stabilized, 3I Atlas changed course again. This time, it wasn't a drift. It was a correction. Observatories in Chile, Spain, and Japan detected a secondary deflection, smaller than the first, but perfectly aligned with its original trajectory. The movement was symmetrical, calculated, exact. It looked less like chaos and more like a spacecraft executing an automated navigation adjustment. The IWN issued an internal alert labeled a pattern recognition event, meaning the behavior matched no known natural process. Simultaneously, the European Space Operations Center circulated an encrypted update confirming measurable acceleration inconsistent with gravity. In plain terms, the object had fired something. Infrared analysis from the Very Large Telescope in Chile revealed a sudden spike in thermal radiation, a burst lasting 12 minutes, followed by rapid cooling. The signature resembled an engine ignition and shutdown sequence. 3I Atlas had just demonstrated autonomous motion. The moment this data surfaced, space agencies scrambled. NASA doubled its observation schedule. China reactivated its U-22 radio array, normally reserved for lunar missions, to monitor deep space frequencies along the object's path. ESA initiated emergency planetary defense protocols. Officially, this was coordination. Unofficially, it was panic. Researchers from Caltech and the University of Tokyo compared the acceleration profile to known propulsion systems. The result was unsettling. The thermal curve did not match chemical reactions or ion drives. Instead, it resembled a magnetohydrodynamic acceleration signature, plasma guided by electromagnetic fields, a technology humanity has only theorized for interstellar travel. Then came another anomaly. The object's rotation rate, once stable, began oscillating in precise harmonics every 247 seconds. This wasn't tumbling. It was too regular. It was signaling through motion. As observations intensified, the IWN transformed from a scientific collaboration into a de facto defense task force. The object's revised heading no longer pointed outward, but toward the outer planets. Its path intersected with Jupiter's orbit. Analysts calculated that within months, 3I Atlas would pass dangerously close to Jupiter's magnetosphere, a region capable of generating enormous energy. If accidental, it was extraordinary. If intentional, it was preparation, a gravity assist. That realization triggered Level 3 contingency, a classification meaning the object's movement was active, intentional, and unpredictable. Then something even stranger occurred. Radio interference across Earth's observatories began synchronizing, all matching the object's rotational pulse. The planet itself appeared to resonate with the signal. And then, without warning, everything went dark. Within 10 minutes, observatories across Hawaii, Chile, Italy, and South Africa lost telemetry simultaneously. The Deep Space Network went silent. China's arrays detected nothing. 47 minutes later, data streams resumed. 3I Atlas was gone. Not destroyed. Not hidden by the sun, simply absent from every registered coordinate. Yet something remained. A faint, low-frequency pulse repeating every 247 seconds. At first dismissed as noise, until the timing proved exact. It matched the object's last known rotation, echoing through space like a lingering footprint. The IWN classified the incident as Interstellar Signal Anomaly 2025-11, restricting all access. But one detail leaked. During the blackout, telescopes briefly recorded a faint, directional flash aligned perfectly with Jupiter's orbit. The object hadn't vanished. It had jumped. Chaos followed. No statements. No briefings. China released a single line before wiping its archives. Tracking anomaly terminated. Object unobservable. For a week, no one knew where 3I Atlas had gone. Then the James Webb Space Telescope detected a faint reflection beyond Jupiter, moving at an impossible speed. Orbital analysis revealed the unthinkable. The object hadn't drifted or accelerated. It had relocated instantaneously, faster than light. Impossible until Gaia confirmed it exactly 247 seconds later. The pulse didn't fade. It multiplied, as if 3I Atlas had learned to use gravity as a bridge, moving through space-time itself. Then came the most disturbing revelation. During the 47-minute blackout, a hidden data stream had embedded itself inside the observation network. Binary, structured, synchronized to the pulse. When decoded, it formed coordinates, not for space but for time. 6 years into the future. The location wasn't Jupiter. It was Earth, a precise intersection with our orbital plane in 2031. The file was locked under asteroid hazard level 10, a civilization-level threat. Every agency denied its existence. Yet 3 months later, amateur astronomers in Australia detected the same pulse, this time from inside the asteroid belt. It wasn't leaving. It was coming back. That was when the asteroid warning network went dark permanently. All public data vanished. Official reason: system restructuring. Insiders claim a private, encrypted observatory network was formed outside government control. Its codename: Project Helios. Its mission: track whatever 3I Atlas has become and prepare for its return. Because maybe the object wasn't escaping. Maybe it was mapping us. And every 247 seconds, a faint echo still ripples through the solar system, quiet enough to hide in cosmic noise, strong enough to remind us the story isn't over. The world may have forgotten 3I Atlas, but the universe hasn't. So if this made you question what's really moving out there, what intelligence might be guiding something across the stars, don't look away. Subscribe to this channel. We uncover the discoveries agencies won't admit exist. Turn on notifications, because when 3I Atlas returns, it might not just pass by. It might be coming home. Rocket. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.